So we are in example 6, the only example number 6 that we have. And we are going to go and subtract cosine from both sides. Again, two trig functions. They're stuck together. There's no way to kind of change them up. It's not like a tangent that we can start changing to sine and cosine or something like that. So we're stuck with the sine and the cosine on each side. Move them over so they're separated from each other. And then we also have this little issue right here is the theta over 2. So we think about, is there any identity that gives me sine over theta over 2? And yes, there is. It's the half angle formula. And there it is right there. We are going to use this identity, plug it in, and let's see what we can make out of it here. All right, that looks a lot better. At least I'm getting to the end. I have two trig functions. They both have cosine theta inside them. I think that'll work. Let's go for it here. Let's square both sides. And let's see what happens. This guy is going to cancel off this completely. I'm at least have that on my hands. And this one. All right, anybody can do this the fast way. Algebra 2. It looks like this right here, right? This one was, if you were to square the same thing here, gets me x squared, negative xy, and another negative xy, negative 2xy, and negative y times negative y is positive y squared. We good? So we're going to use that little rule from algebra. So what I do is I square my first term, then I put a minus sign on minus 2. Then it's the first term multiplied the last term. So 1 times cosine just gives me cosine theta. And then what we do is we square the last term. That was somewhat easy. All right, and if you wanted to really do it the slow way, you can. Mr. H, come on. Surprised me of doing FOIL. So 1 times 1 is 1. That'd be a negative cosine theta, another negative cosine theta, and then it'll be a positive cosine squared theta. Are we good there? Still gives you the same thing. Karen, doing okay?
We're like scared of being caught in the recording, you know, the same thing.
All right. Solve for cosine. All yours here. Talk to me here. So I'm going to bug people as I go. Grant, what should we do to solve for cosine theta?
I mean, I bet you can factor.
Ooh, let's see. I think I don't want to factor yet, but I do want to set it up for factoring. So I do want to set it equal to 0 so that I can start factoring. So.
Can you multiply by
Multiply by 2.
Multiply by 2? I think I'm going to do that, yeah. Let's multiply by 2.
Just do the whole thing. That kind of sucks.
1 minus cosine theta is equal to 2 minus 4 cosine theta plus 2 cosine squared theta. These got complicated really quick here, huh? I like 6.1 a lot better now. Okay, now I think I can move things around. I'm going to subtract 1 from both sides to get this guy over here. I'm going to add cosine to both sides. I think I should get what I want here. Adrian, if I do that, what do I get?
Well, 0 on one side, and then 1 minus 5, or 1 minus 3 cosine plus 2 cosine squared.
I go with that, yeah. 1 minus 3 cosine theta plus 2 cosine squared theta. I don't like to see it this way. Can we do it like this? I'm going to put 2 cosine squared theta minus 3 cosine squared theta plus 1 is equal to 0. We good? Flip them all across the equal sign and then put them in the order that I like. All right. Zechariah, what do you say? Factoring or quadratic formula? Quadratic formula, okay. For this one, you could use factoring. It wouldn't matter which way it goes. See, this is where I get to change it up. Like, that's great, Zechariah. Okay, let's try factoring.
Wow.
Okay, I have a,
Just kidding, Zechariah. We can go both ways.
so I heard with like the diamond formula, you could do a fancy thing where you do like the numbers you factored over the A value and then plug the A value into the like final equation. Does that make any sense?
Oh, totally, yeah. We should do that sometime.
Yeah. Could you show how to do that? Because it
Sure.
seems like it'd be helpful to know, and I'm not
Sure.
sure I fully understand it.
Let's do that. Let's finish off this problem first, and I'll show you the trick after that, just so it doesn't break off the problem.
Would this one not work with that?
This one totally would work, yeah.
Okay, cool. That's because I just tried it really quick on paper and wondered if.
Awesome, okay, let's do that here. So let's do, since Zechariah said quadratic formula, let's go with quadratic formula. Negative b, so 3 plus or minus the square root of b squared minus 4 times a times c all over 2 times a. We're good with that? Interesting, okay. Then I'm gonna have 3 plus or minus, what is that gonna be, 1? Oh, 2 times 4 is 8. 9 minus 8 is 1, and then that's gonna look like this. And so I get to have 2 answers here. Let's see, 3 plus 1 is 4. So 1's a 1, and 1 is a 1/2, or 2 over 4, or 1/2. That's what I'm looking for. So now I'm looking for, when is cosine theta equal to 1? And when a cosine theta is equal to 1/2 on my little chart. And let's see, we are in degrees or radians? Radians, okay. So boom. Georgia, that does not have a book with her. When does cosine, give her the answer. When does cosine give you 1? You have to mentally think through a unit circle. And you're looking for x value of 1. Boom, like that, right? And unit circle is the highest it can go out as a 1 anyways. So I'm gonna go with this one right here. Is that okay? Yep. Uh-huh.
Yeah.
Okay, I got 0 in my hands here, and then I have a 1/2. Nicholas, do you have a book? You know what we should do? We should do like a unit circle test. Make you guys, that would be fun.
Epic, yeah.
With the book.
No, but it should be like a surprise test.
Ooh, yes.
Yeah, so
Oh,
if you
yeah.
have your book, you pass it.
No, we do like a communist test where we all work together.
So just class.
Yeah. Yeah.
Our test.
Yeah.
So let's go with this one here. Let's see. I always put little 3 dots here because it helps here. So if you go from 1, right, you go backwards along the x-axis, you're going to get smaller and smaller, right? So 1 is all the way at the end. That means this has to be square root of 3 over 2, square root of 2 over 2. That has to be the 1/2 right here. So boom, angle measurement, Nicholas, is in radians. Yeah, no problem, go for it. And then let's see, the other one is gonna happen on, oh, not in quadrant 2, not in quadrant 3, it has to be in quadrant 4. It's gonna be down here again. It is that much away from 360. 3, I put that, or we can do degrees first, right, if you want to. If you're so used to degrees, put degrees, 60 degrees, and then change it to, right? What do we get, 5 or 3? There you go. Just say yes, everything will be great. And Amaya, one more here, right there. What's this guy here?
Thanks for that, Adrian.
Why?
Okay, to make this a little faster, let's go with it. I got, okay, we got 3 answers here. What do we have to do? We have to check. So 0, pi over 3, 5 pi over 3. Make this a little faster. I have Karena and Hayden. Can you guys check 0? Amaya, Haley, and Rylan, can you guys check pi over 3? Georgia and Nicholas, 5 pi over 3. And I'll figure out a way to make Blastro suffer a little bit later. Say again, say again.
Just, I don't think either of us have books to do.
Oh, okay, so that's right. So row 4 has to help with row 3's work here.
You're gonna be like a lower graph over there.
In what way?
You're right now.
You?
You're now.
Why am I putting myself into zero?
Yeah, it's really.
It should not be on.
All right, the only thing they're going to be careful for is that sine theta over 2, right?
We own that.
What?
Okay, but.
Reverse
there's
capitalism.
Okay, in this situation, there's also some sort of deity telling you to help us for free.
Right.
So-
Help you guys with it or no? You guys
No,
okay?
I think we're good.
Okay.
Okay, I think
Exactly.
I'm gonna do this one because this is the toughest one here.
Five pi over
Yeah.
three.
I got it, I got it, I got it.
It's like
Got
something
that.
I don't know where is that.
somewhere. It's negative root
But that's
zero
it,
two.
it's, oh wait, so what do you have?
What is?
You think
I'm
negative
pretty
root
sure
zero
you're
two?
not
agree.
It's okay.
I got not equal three.
Yeah.
Okay.
1/2.
For a second, I thought you was very wrong.
By the way, hi.
1/2.
Yes, root tree over 2.
If you're on
Tree
power.
root.
It's tree root. Oh, you gotta.
You
keep
three?
tree root.
Did you confer?
Yeah.
Said a no on this
Tree
one?
root cube.
Okay, let's go with it here. So sine, so 0 worked. Sine of pi over 3 over 2 plus cosine or minus, which is it? It's plus. Cosine of pi over 3. Question is, does that equal to be a 1? I don't know, but we'll find out. This little guy, pi over 3 divided by 2. What'd you guys get for that? Pi over 6. Sine of pi over 6 plus cosine of pi over 3. Still a question mark here. Sine of pi over 6. What'd you guys get? 1/2? 1/2 with the yawn? This one? I
Or is it one?
think it's 1/2.
Never
We got
mind,
it.
then it does equal. I
Okay.
did that.
And this one checks out as well. Nice. I like that one here. Okay. Row 3 with vassal lords of row 4. What'd you guys get?
I misspoke the first time, so I need more information from them, and then you were doing, so, yeah. Okay, do you guys wanna help?
I helped, but apparently it was the wrong thing.
Okay.
So this one is 5 pi over 3 over 2 divided by 2. You can either just multiply the denominators together, or what you do is you make this into that. And in your mind, at least, you multiply by the reciprocal, right? So it'd be sine of 5 pi over 6 So notice,
Yeah.
notice it's interesting. If you have a denominator here and denominator here, you can multiply them.
Yeah, that's true. Guess what the sign of that is?
Okay, so then, yeah, it does equal one.
Oh, God.
It does.
Yeah, 1/2 right here. That's 1/2.
Yeah, if-
That
yeah.
is perfect. Okay. Boom.
Wow.
Okay. In this instant, all of them work. That's cool. So final answer, theta is equal to 0. Also pi over 3. Also 5 pi over 3. Boom. Okay, we're good there. Okay, Gemini? Everybody okay with number 6 now? Okay, so now if you have your calculators, we're gonna verify our answer graphically here. Well, let's solve this algebraically first, just so you guys have calculators out here. So here's what I have right here. Gets a little more complicated, but that's fine. So 0 to 360, we're in degree mode. We're gonna solve it algebraically. Then afterwards, we're gonna just check to see if that is correct.
So this instead of plugging the vector?
Yeah, But this one, we don't need to plug in because we're not gonna square both sides. Cool, okay, let's jam. First things first, I like sine, cosine, and tangent. If I can get to those, that would be great. So I think I'm gonna convert this guy into cosine over sine. Again, it's an identity, I can use it. This be 11 cosecant.
It's one of them.
It's cosecant. I think it's 1 over
Turn it into something.
the something would work, yeah. And 6 sine theta, that one is by itself. So all yours, see if you can get ahead of me here. If not, I'm just gonna stick around, wait for me here. But I see denominators over here. So first things first, how about this? It's gonna be over sine. This is gonna be 11 over sine theta. That, let's see, I can make both denominators here. So sine theta here, this will be 13 cosine theta plus 11, all equal to 6 sine theta. That's at least as simple as I can get it, right? On that side. Now we have to multiply. Before I can multiply by sine theta, I have to declare something because I can't multiply both sides of an equation by 0. I can multiply any other number whatsoever. So off to the side, we say sine theta does not equal to 0. If I get that answer, I'll have to discard it. And now that allows me to do that here. So sine theta on one side, boom, boom. Sine theta on the other, that cancels, and I'm getting closer. 13 cosine plus.
Wait, when do
Yep.
you know that sine theta equals 0? When you're multiplying it by?
I have to somehow clear the fraction. That's my little problem. So to clear the fraction, I have to multiply whatever's here, but I can't multiply by 0 on both sides.
Oh,
So
okay.
I can multiply by any other number besides
Okay.
0. So I just have to declare that for my final answer, I can have sine theta equal 0. 13 cosine plus 11. Sine plus 11 is equal to what? 6 sine squared theta? Is that right? Boom, boom, boom. picking on people. That's no fun. Okay, Nicholas was the last person. I may get to pick on you.
Yes.
So all yours. What should we do?
We're trying to get one side equal to 0, right? Or is that?
Now I still have two trig functions here that I gotta deal with. And I don't want to have them two different trig functions.
So see if we can turn sine squared theta into 1 plus cosine squared theta.
Cool, let's see. Pythagorean theorem says, off to the side, Pythagorean theorem says sine squared theta plus cosine squared theta is equal to 1. So if I'm going to substitute, sine squared theta is going to be 1 minus cosine squared theta. Are we good there? So there's a substitution, 1 minus cosine squared theta. Man, that good?
Yes.
Okay. And then notice I had to put parentheses here because the sine squared theta was one single piece. Now I have two different pieces. Careful, I saw that on the homework the other time. Someone didn't put parentheses there, so it was like 6 times 1. That's great. But the 6 has to multiply to the 1 and also to the cosine squared. Okay, now we're looking for trying to make it go to 0. So Haley, all yours here. What should we do?
Would you subtract one?
Absolutely. We can go either way, right? We can go this way if you like. I almost prefer just to go the other way because this was going to give me the 0 on the left. Sorry, on the right-hand side. Almost want to do this one. Minus 6 here. I'm going to add 6 cosine squared theta over here. That will get this all right-hand side to 0. And this is nice setup already for me. Boom, 13 cosine x. What is that, plus 5? Dun, da, da, da. Right, Lynn, all yours here. So quadratic formula or factoring, whichever you prefer. Whatever you say, that's what we're gonna go with. Boom, okay. Let's see, opposite of b, plus or minus, the square root of, 169, I believe, minus 4 times a times c all over 2 times a. Whoa, those are huge. And everything's positive? Yeah, everything's positive, okay. Brenna, what's inside the square root as we put this together here? What's that stuff? 169 minus whatever that is. Oh, awesome. I like when things work out. So that means negative 13 plus or minus, what's that? 7. So that is negative 13 plus 7 is negative 6/12 or negative 1/2. Going the other way, negative 13 minus 7 is negative 20 over 12, negative 5/3. That's what I got. Oh, good. Is that what you guys got?
Did the top one say negative 1/2?
Negative 1/2 eventually, Let me erase this here. Okay, so then I'm looking for when is cosine theta equal to a negative 1/2? When does cosine theta equal to a negative 5/3? Boom, unit circle. I know I'm in quadrant 2 and 3. Like that. And let's see, cosine is going to be kind of like on the upper tier right here. Doing. And then it's also going to be on the bottom right over here. So it's the 60-degree angle back from 180. All right, let's see. Theta is equal to 120 degrees, is that right? Because it forms that 60-degree angle right there. Why am I forgetting to bug you guys here? Hayden, all yours for the next one then. We're from 60-degree angle away from 180. 240 is perfect. Okay, and then Grant. Back to Grant. Grant, when is cosine theta is equal to -5/3? It's a tricky question. Go ahead.
It looks like you're reaching your phone to your phone.
Absolutely. I'll show you the dot though. The dot is at -5/3.
Oh, right, yeah, wait,
It's a word that starts with an N and ends in ever.
yeah.
Never. Now, can't have anything that's higher than 1. You can't have anything that's less than -1. So in this case, you can put never. What's the little funny symbol that we use? Fat zero, slash through it. That's great. Okay, so calculator wise, I mean, we didn't get to your factoring little trick here.
I did it with this problem and it worked.
Okay, cool. Okay, it is a nifty little trick. I'll have to show you guys on Wednesday then. Okay, with 2 minutes left, let's jam to our calculator. So we want to be able to see if this.
So are we just trying to see if they're both the same one?
We are trying to see if they intersect at that spot. So we'll move over here. Let's go with the problem itself here. So first things first, turning on my calculator. Clearing screen mode. Let's go to mode. Mode, we're going to be in degrees. So move it over to degrees. Click and enter. That's cool. Go to y equals, and we have 2 different lines on our hands. We have a, okay. So our calculator does not have a, let's talk about this here. Our calculator does not have a cotangent inside it. Can I, instead of using sine over cosine over sine, can I just use tangent? Is that okay? You guys, will that be the same thing? So I'm going to do this here. 13 divided by tangent theta, or tangent x in this case, plus 11 divided by sine of x. Are we okay with that? Me converting those? So 13 divided by tangent plus 11 divided by sine would be my first. Okay. Thank you. Thank you for telling me before I clicked
Or
that.
everyone gets confused.
Yeah. Thank you so much. Okay, we know not to trust Grant. Okay, back to my second equation, 6 sine theta. We're good. I got 2 equations here. So what I want to do is I want to go to, let's see, I'm in degrees. I want to go to my window. Actually, no, let's do this. Let's click zoom and then zoom trig, number 7. Just sort of see what that's gonna do, and then we can kind of hone in what we want.
Oh,
Whoa. Okay.
fun.
That's interesting.
Okay.
Okay, so.
It's called wrong.
So I think we need to expand our y up and down. We do need to go to 0 to 360. So now let's go to window. Windows going from here to here. Okay, let's go from 0 to 360. And the tick marks are at 90. I can make them, it doesn't really matter here. Make them like 30 degrees on the tick marks. Okay, this one we have to expand out a little bit here. So how about negative, let's go negative 10 to 10. Let's go standard, let's see what comes of this. And then the graph, let's see if this works a little bit better. First graph. And then second graph, there's 1, 2.
It's not
Oh.
gibberish anymore.
Mm-hmm. Looks nice now. Okay, so we're just trying to figure out that little guy right there. So what we're gonna do is we're gonna go to calculate right here. This little calculate button, and we're gonna go down to intersect, because we just want to know where these guys intersect.
Yeah, it's the one right there.
Click on it. It's what's gonna do. It's gonna jump to a first curve. You can go with arrows. You can go up and down. Notice the first curve is right there. I'm gonna try to get close to this guy over here.
Wait, to which one?
My little cursor, getting closer to that first one there. Oh, I'll
How
go
can
slowly.
you tell when you're at the intersection point?
Yeah.
Sure, we'll do it in just a second. So first of all, we've got to name which curves, because the calculator assumes you have a whole bunch of different equations. And it wants to tell, you need to input it to tell you which two curves you're looking at. So first curve is yes. Second curve is that one, yes. So click enter. And then the fun part begins. You have to enter a guess. So what you want to do is you want to just get close to the intersect point right there.
It wants you to guess.
Guess.
That's cool.
Wait, how do you do the guess? Or
Sure, let's do it again.
because
So-
I have first curve question mark.
Yeah, first curve, so intersect, click on it. So first curve, just click enter.
That's cool.
Click enter.
Yeah, click
Oh,
enter.
now it says second.
Second curve, click enter again, because we only have two, we only
Oh,
graph
yes.
two equations, right?
Yeah.
Won't let me go.
And then they're just gonna get close to the answer right here, just close where they intersect.
Oh, it's thicker. Why is it thicker? There.
Because you pressed enter.
Oh.
Okay, let me walk around.
Oh.
Who,
You see how it's thick? Wait, it's not thick on the wall.
You could have had a different graph scenario there. Real quick here, talk to me here. Who needs help with the calculator on getting the 120? Rylan got it?
My calculator's dead.
Okay, never mind. You didn't get it then.
So yes, I got it.
I need help.
Okay, am I good there? I'm gonna stop with that then. Get the other one?
The only answer is
120. Then we're
Wait,
gonna go to the
how
other
did
one.
you- How did you get 120?
120 is this little X right over here that says 120 for me, but let me help Amaya here. Let's do this here.
If we didn't have to do the square root thing, like you said at the beginning of the problem, like we're checking it, but we wouldn't have to plug it back in because we didn't do the
Squaring.
root, right?
Uh-huh.
Why is only one of the solutions that we got correct?
Oh no, there's your one, the 240 should be right here. Let's check this one here. So let's go to calc. Intersect again, which is number 5.
Oh,
And then we go to first curve. Now we're gonna go here. Now you can actually click on first curve here, right? Because we only have 2 curves graphed, so it doesn't matter. So first curve, enter, second curve, enter. Now to guess, what you have to do is you keep on going until you're close, super close to this answer right here. Click enter. It'll do some number crunching. Da 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 da. And there's our 240. So we got both answers. Okay, we're good. If you have some calculator issues, come talk to me. Otherwise, I'll see you guys on Wednesday. And enjoy the rest of your Monday.
I got it. I got it out. So both answers are 120 and 240.
Yes,